talk just a bit about the Stacks 2.0 blockchain and its surrounding ecosystem. But first, a bit of background. What exactly is Web3? What is it good for? What problems does it solve? Well, if you take a high-level view of Web3, it's best to compare it to Web 2.0 to see what the key differences are here. If you look at Web 2.0, it looks a bit like this. Anytime you want to share data with somebody else or do any sort of stateful work on a web app somewhere, the app owns the whole process end to end. Suppose I'm using Facebook. I want to share a picture or a post. I have to sign into Facebook, upload my photo or my post to Facebook, and then have my friend sign into Facebook to go and see it. Facebook gets to store my data, they own my data, they decide who gets to sign in, and they decide who gets to see anything. You see, this creates a very unfortunate power dynamic that Facebook has because they own everything. And we, the users, despite bringing value to Facebook by interacting with it and storing our pictures and our posts there, we see none of the benefit. Facebook gets to reap all of the benefit from us all doing this work. And moreover, even if we wanted to do something about it, like change the client or change the backend, we can't because we have no real power to write our own clients or replace our own backend services. That's the Web 2.0 world in a nutshell. Apps own everything, users just have to deal with it. In Web 3.0, we flip this power relationship on its head. So now, if I want to store data, it goes to a storage location that I choose. I encrypt that data before it leaves my computer such that only the people who I want to see it may decrypt it. If I want Facebook to see it at all, I make it so that Facebook has the privilege of doing so, but only as long as I say so. The app serves at my pleasure. I own my data. I choose who gets to see the data. I don't even need to keep using Facebook. I can make my own clients for my data because Facebook is now just another client of my data, and they are just as replaceable. In this world, users own all their data and identities, and Facebook is a replaceable commodity that simply serves to download and index my data on behalf of other users to try to add some more value, just like anybody else does. Now, if you squint a little bit, you might have noticed in that previous diagram there were no servers. Well, there still has to be some server. There has to be some way to coordinate reads and writes to our data so that if I put something online, other people can go and find it. And in the Web 2.0 world, if you the Web 3.0 world, if you drill down into it a little bit, it'll look a bit like this diagram here. There's two paths. Parts 1 and 3 are concerned with storing the data. So when I want to store data in Web 3, I put the data into a storage repository of my choice, but then I have to also announce the existence of that data, namely give it a name of some kind, as well as a URL and a cryptographic hash of that data. And I put this information into a program called a smart contract. And smart contracts are these tiny little programs that live on the backbone of Web 3.0 computing networks called blockchains. So in doing this, I make my data discoverable to anybody who wants to go and index this blockchain, or also to users who happen to know the name of the data that I put online. So when my friend goes to get my data, they would read the smart contract state. They would look for the URL that I posted earlier. They would fetch my data from wherever I happen to store it, and they would use the hash that I put to authenticate the data so they know it came from me, and they're not trusting the storage provider or the middleman delivering it. So at a high level, we still kind of have this notion of servers. It's just that the server itself is now this digital commons that nobody and everybody happens to own. And when people are building apps this way today and have been for some time, and Stacks 2.0 is a system that makes this particularly straightforward and monetizable. But first, a brief history. What have we been working on here? So this has been a very long endeavor. So we all know and love Dr. Munib Ali. He's been working on this since early 2013 when I first met him, when we worked in a lab together at Princeton over a summer. Shortly afterwards, he got together with another Princeton alumnus, Ryan Shea, to start a company called OneName. OneName's job was to make it so that you could give a username to a Bitcoin wallet and thus make it really easy to share cryptocurrencies. And it was a success. Munib and Ryan got accepted into the summer class of 2014 at Y Combinator, a prominent venture capital firm and incubator in Silicon Valley. And they ran with it, and they were able to turn this into a viable product. In 2016, I was hired by Munib to port the one-name system to Bitcoin. Now, this was an interesting challenge because over the course of doing all of this, Munib is still working on his PhD, the superhuman that he is. And in doing so, he discovered that it's actually very risky to build systems on top of other blockchains because they can get attacked and no one will notice because they're small and they're out of the way and nobody really cares. This happened to the system that we had been using on OneName. That system was called Namecoin. And for a long time, somebody had over half of the mining capacity of the Namecoin blockchain, which meant that they de facto controlled the entire system. And that's not okay. That's not what we're trying to go for here. So I was hired to port it onto Bitcoin, which does not have this problem. And the system was a success. It kept working. And in 2017, Munib managed to raise a Series A with his co-founder, with Ryan Shea from Union Square Ventures, for $4.1 million. And only after that, Munib gets around to finishing his PhD and defending it. He had done plenty of work on search engines and cloud computing and virtual machines, but he actually ended up not writing about that for his PhD thesis because the stuff he was doing for Blockstack was so new and groundbreaking that that alone was sufficient to write a PhD for Princeton. So his PhD is just on the Blockstack system and the types of apps and architectures it unlocks. Also, in the very end of 2017, Blockstack, the company as it was called at the time, did an accredited token sale. So they sold STX tokens to accredited investors, and they managed to raise $47.5 million in the process. Shortly thereafter, in 2018, we developed and we launched the Stacks token so it could be bought and sold and traded on exchanges. But in 2019, what Munib and Ryan managed to do was they carried out the first ever SEC qualified token sale in the United States, whereby the United States government gave us permission to sell these tokens to non-accredited investors, and also in the United States and also as well globally, without getting into any sort of trouble. Now, this is particularly important at the time because this is just at the tail end of the ICO boom from 2017 or so, where regulators in the United States and elsewhere have started to take notice of the rampant frauds that have been going on in these things. So getting the SEC's approval was a very involved process, but we are so glad that we did it because we're now seeing SEC action being taken against firms in the United States that were not as diligent about who they sold their tokens to. So shortly after doing this, we created the Stacks Foundation because we really believe that the system we build should not be under the control of a single entity if it's meant to serve as this digital commons. I was on one side of this split, the Stacks Foundation, and that's where I work today as a research scientist. And about 2 months ago, we finished building and launched the Stacks 2.0 system, which is our master design. It's a full blockchain in its own right. It uses Bitcoin for its security, and Blockstack renamed itself to become Hero Systems, and a couple other entities further split off from there, so that the economic ecosystem surrounding our blockchain is fully decentralized, as well as its governance process. But the point is, this has been the work, a culmination of years and years of work of distributed systems research and development, guided by no fewer than 6 separate PhDs working on this, all of whom study distributed computing for their theses and continue to do so by working on Blockstack, now known as Stacks. So why did we do this? What motivates us to do this? What was Munib's original idea? Why go through all of this pain and suffering to build this really elaborate computing system that, when the cloud already exists and largely does all of this type of work for you? So the cloud can't do a lot of things, the kinds of things at least that we want. We want there to be a way for people to build web services that are highly resilient and manage to have their own state. So this notion of a global shared state that anybody can read and write. But such that there aren't any servers anymore. You see, the problem with servers, and by extension, the problem with clouds, is that you don't own them. Somebody else does. And that person can decide to just deny you service and take away the services you were working on and building, largely on their own caprices. And this is a problem that has plagued the world of web services, mainly because it makes it that much more difficult to build systems that users can expect will stick around. And there's not even any malice in that description either. Like, companies go out of business, for example, and they take their servers with them, so that app that you happen to like and use no longer is available because, that's just the way that business is done with running servers. So we want to make it so that apps become part of this digital commons that we're trying to build. They don't die when their creators move on. They only die once people stop using them, and not before. So to do this, we need to have this resilient, stateful, serverless API platform that can keep running as long as the users who cared about the app are still around using it. In order to facilitate this, we also want to make it so that users own all their IDs and all their data online. They can't get locked in, and if a server goes down, it doesn't take the data with it. So that's a prerequisite to realizing this world here. Now, this is also a challenge because the lack of lock-in mechanisms makes it hard to raise money to build apps that are built this way. So we need a different way, a faster way if possible, to begin monetizing successful applications that create this digital commons in which users own their IDs and their data online, as well as to raise money off of it. So with these 3 points in mind, we designed the Stacks system. Now, why Stacks? Why use Stacks over any other blockchain? This story is not unique to us. Several other platforms are trying to build a new type of web. Well, Stacks brings 4 things to the table that no one else has. The first of which is a novel consensus protocol called Proof of Transfer, or POX. Now, what POX lets you do is if you promise not to spend your stacks by locking it up programmatically, the system will pay you a Bitcoin yield. So not spending your stacks is like putting it in a bank and getting interest, except that interest isn't more stacks, it's actually in the underlying Bitcoin currency. The other thing that Stacks brings to the table that's really new is this new programming language for smart contracts called Clarity. Now, unlike other systems in this space, Clarity is a decidable programming language, so you can't write arbitrary algorithms, but it's still very expressive, like expressive enough to do the things that you would realistically want to do in smart contracts. And it's also much safer because it offers several proactive protection measures to keep users' digital assets safe, as well as ensure that you can reason about all of the possible things a Clarity program can do. The 2 other things that we bring to the table are a bit further out in the ecosystem, but are still used in production today. And those are Gaia, which is a storage layer that sits on top of commodity cloud storage, as well as decentralized storage systems like BitTorrent or IPFS. And it makes it so you have a uniform API for reading and writing your data. So developers don't have to integrating particular storage systems into their app. The user can instead bring their Gaia hub to the app, and the app reads and writes the user data through that user's Gaia hub. And that's facilitated through the sign-in process that the Stacks ecosystem also supplies you. In addition to Gaia, we have a system called Radix, which is kind of like a decentralized MongoDB. It indexes Gaia hubs, and it provides a MongoDB-like interface, but it doesn't actually see the data, or at least doesn't see any data that you don't want it to see. All it does is it maintains indexes and makes it relatively easy for you to discover other people's data. If you want to run your own Radix server, you certainly can. So you're not locked into a particular Radix server should you choose to use an app that uses Radix. Now, why Clarity? Why not Solidity? Why not an existing programming language? So Clarity is a domain-specific language. We wanted to solve the following things. First, it should be possible to make serverless application backends. So you can make API endpoints out of Clarity that your apps can call into, but there's no server behind them. There's just the blockchain network that executes those API calls as transactions. Or if they're read-only, it simply evaluates them in place on the current chain state and gives you back the result. So this way, for example, in our toy app I mentioned earlier, the act of storing new pointers to content would take a transaction, but the act of discovering and reading them is completely free, like no transactions required at all. You're just hitting a RESTful API endpoint implemented in Clarity. The other thing Clarity gets you is native support for tokens and NFTs, and with it a whole bunch of safety features to ensure that bad or buggy smart contracts can't just steal your tokens. The system has a proactive security mechanism in place called post conditions, whereby you, the user, specify in advance what tokens, if any, will move during the execution of a transaction and how much. And if those post conditions are violated when the transaction finishes, then nothing happens. That way you can proactively keep yourself safe from buggy code. And if you look at the history of smart contract platforms, it's really the history of buggy code eating other people's money. So we protect people from this. A really novel thing that we're just now getting started with is we can make it so that you can write smart contract code that pays you in Bitcoin just by existing and by people using it. This can be facilitated in at least 2 ways, and I have links to starter kits here if you want to start working on variations of this. The act of locking up your stacks to earn Bitcoin, we call that stacking in the stacks parlance. That is controlled programmatically through a smart contract. In fact, it is a smart contract that lives at the very genesis block of the blockchain. And other Clarity contracts can call into it. I have a starter kit linked here called the Stacks Future contract that lets you do the simple thing of lock your stacks, but produce in one-to-one a futures token that you can still trade, such that when your stacks unlock, you can just redeem them. Whoever owns those futures tokens can just redeem them back for the original stacks. Another example of this is you can make it so that the act of producing an application-specific token can give you a stacks yield. And to do that, you simulate mining, the way that it happens on the stacks blockchain. To make this happen, you would make it so that you need to possess or spend an app-specific token to access certain parts of the app, but you make it so that the act of producing those tokens is the act of other people spending stacks and putting them into that contract in order to mint them. Now, you have the option to either spend these app-specific tokens or lock them up, much like how you lock up stacks to get a Bitcoin yield. So that the act of locking your app-specific tokens gets you a payout in stacks, which you can then stack to get a Bitcoin yield, thereby yielding code that earns you Bitcoin. I have a starter kit here called POX Lite or Poxel that you're more than welcome to take a look at and use however you want. Now, Clarity as a programming language, you might have gotten the hint earlier, it's based on Lisp, so lots of parentheses. It's a strongly typed Lisp, so the program is type checked before it runs, and we make sure that everything is fine. There's as few surprises as possible at runtime. The type checker and the analysis part of the language will try to stop you from accidentally writing buggy code to the best extent possible. But that said, it is a recitable programming language, so there's no recursion. There's no reentrancy, so I can't have contract A call into contract B, then call back into contract A. That's not allowed. There's no unbound loops, so you know how many iterations happen whenever you loop in advance. And there's no anonymous inner functions. You have to define all functions are top level and inlineable, and the only way you can invoke them is either through calling them directly or through the helper functions filter, map, and fold, which if you are familiar with functional programming languages are the bread and butter of getting things done by calling functions repeatedly. Anyway, the nice thing about Clarity when you're learning it and when trying things out is that it's all visible on chain, because unlike existing smart contract languages, Clarity is interpreted in place. So if you go to the Stacks Explorer, explorer.stacks.co, you can see all of the code that's already been published, and you can use that to help learn new techniques for writing Clarity code. So with that, I wish you all the best of luck, and I hope that you enjoy Stacks 2.0.